Apache Spark is a core technology for large-scale data analytics. Microsoft Fabric provides support for Spark clusters, enabling you to analyze and process data in a lakehouse at scale. Apache Spark is an open-source engine for distributed data processing and is widely used to explore, process, and analyze huge volumes of data in a data lake store. Spark is available as a processing option in many data platform products, including Azure HD Insight, Azure Databricks, Azure Synapse Analytics, and Microsoft Fabric. One of the benefits of Spark is support for a wide range of programming languages, including Java, Scala, Python, and SQL, making Spark a very flexible solution for data processing workloads, including data cleansing and manipulations, statistical analysis and machine learning, and data analytics and visualization. Now, because I have already my workspace in Microsoft Fabric created, let's reuse it and carry on with this lab. So I have already created my Fabric workspace, as you can see on the screen right now. My workspace is named MS Learn Fabric. When I click it, I can see my previous lab created, which I'm not going to delete for the reason to keep all the previous labs created and runnable. And now, so we have this workspace created, we don't have to create new one. So in the next step, let's go to the Synapse data engineering. And here we will create new lakehouse. Yeah, so we can create new lakehouse, clicking this button, and we call it lab 02. Let's create it. And now I'm going to download the orders zip file, which I've done a few minutes before. So let me open that. And here's my file, which I will unzip, putting all the files to the new folder. And I have my all files here. Let's then upload these files to the files folder here. Okay, let's click upload, upload folder, and then I will choose the folder that I just created. Orders, this is the one. Okay, upload, upload all 3 files, which should be done in a few seconds because those files are small. Once we close it, we can see that we have folder orders. And if we click on this, we should be able to see all those 3 CSV files uploaded in here in one lake. To work with data in Apache Spark, you can create a notebook. Notebooks provide an interactive environment in which you can write and run code in multiple languages and add notes to document this code. So now in this home page, if we see this all the documents, we can have this we have this open notebook menu. If you click this, we can open existing notebook or create new notebook. Let's create new notebook right now. And let's rename it like lab 2 notebook 1. Okay. So now my first cell is the code cell, but actually I would like to change this to the markdown cell, which is not code, which is like just the comment formatted kind of documentational cell. So let's click this, and now we can change this using using markdown language. So let's say we says here sales order data exploration, and yeah, use this code in this notebook, to explore sales order data. Okay, so this is my markdown cell. Now you are ready to run code that loads the data into a data frame. Data frames in Spark are similar to pandas data frames in Python and provide a common structure for working with data in rows and columns. Now with the notebook visible in the Explore pane, we can expand the Lakehouses and click the files, and so for our Lakehouse, and select all orders so that we can see all the CSV files in the orders folder. If we select one of those files and click these three dots here, so we can select then load data and Spark. If we select that, new cell in the current notebook will be created. It will be cell with the code in PySpark. So as you can see, it's reading the CSV file with the headers, loading this from appropriate location. So let's try and run this code. Session started very quickly in 5 seconds, and now we see our data loaded directly from the CSV file. Now also we can hide this and collapse this pane to see more notebook area. And also remember that the first run of the notebook, first run of any cell in the notebook might take a few minutes actually, rather than just 5 seconds, because the cluster itself needs to be started. In this case, cluster started very quickly because I'm using the starter pool clusters. Also, as you probably notice, we don't have headers in this CSV file. That's why the headers doesn't exist. The column names are not correct. So in this case, we should change this header true to header false. And then once we rerun this code, let's do this. Then the headers, the column names will be named by default, like underscore C0, underscore C1, and etc. and etc. Also, to make this address shorter, I can remove everything. The first part, which contains the container ID and storage account name, and I can leave only this starting with files. So let's see if that works as well. It's exactly the same location because we are in the context of this one lake. Now, of course, I would like to define those columns appropriately because I know what's their name. So I would like to define them appropriately. So let's do it in the next cell. We can add new code cell. So I will copy this, but before I do this, I need to add and define the schema. So I need to import one library. Import. Okay, and now I need to define the schema. Struct type, and then struct field. The first field will be sales order number with the type of string type. And I will do the same for the next few fields. Of course, the link to this code you will find in the description of this video, so you don't have to write this everything manually. Now the last thing we need to add here, we need to actually replace this option because we don't want to do anything with the header. By default the header is false, so we want to define the schema from this object, okay, and then load. So let's see if that works. Now we have appropriate column names, and even more, we have appropriate data types, because we defined, for example, for quantity column, we defined numeric, we defined integer type, yeah, and similar situation for unit price, where we defined float type and float type for tax columns as well. So we can see these appropriate types in the by the icon in the next to the column name, which is great, fantastic. So we have appropriately structured table with appropriate data types. Now you remember that we are reading only CSV file from 2019. So let's read all the files, actually replacing this this 2019 name and replace that with wildcard. So this actually allows us to read all the files from a given folder. So let's run this. And now in our result, we should have all the data from all the other files, which contains also the data from 2020 and 2021. As you can see here, this is true. Now let's add new code by clicking this plus code below the current cell. Let me scroll down a little bit. And let me copy paste this code. So now when I run this cell, let's see what happens. So when we run this operation on a data frame, the result will be the new data frame. In this case, new customers data frame is created by selecting a specific subset of columns from the df data frame. So this is this operation. So under this customers, we have data frame. Now what we are doing, we are printing count of customers and count of distinct customers from this data frame. So this data frame provides functions. Always, each data frame provides functions such as count, distinct. It can be used to summarize and filter the data that they contain. Okay. And as I mentioned, from the original data frame, we are selecting only those two columns. So those two columns only will be available in this data frame. So it's something like we're creating the clone of this data frame, clone of this virtual table in memory. And then we can display these distinct customers to the screen, to the output. Now let's modify this cell a little bit and add filtering condition. We have the function where, and my condition would be that any item, show me only the item which is route 250 red, 52. This is name of the product, as far as I remember. We can actually check that if we want, because this is sales order lines. So the item is this, yeah, this is the name of the product that we are selling. Okay, so let's execute this code. Now we have only customers who bought this product. Now let's another cell. and this time we'll be grouping some product. So let's say I would like to just choose this item, this product and quantity, and I would like to group by item. Okay, so let me do this and sum. Okay, and of course display this product sales. So let's run this code, and here we'll see, oops, something happened. Comma. This is the problem. And yeah, now we have the summary. We have the summarized quantity of each product. So we see all these things. Now I will show you something more, which we will manipulate with this data even more, grouping by the calculated column. So let's create another cell, and this time I will import again PySpark.sql.functions import all, and then I will define df sales select first. So I would like to get year only. I'm using year function to calculate year based on one of the column. The column would be order date. Okay, so I have order date. Then I would like to actually change the name for this column of this value. Actually, it's like, it would be like new column, so I would like to call it year. And then yeah, so this is my new column, and then group by this column. Okay, and then I would like to count everything and even order by this new column using this new alias. At the end, I would like to assign this to the new data frame, yearly sales, and that should be it. I hope I wrote this appropriately. We'll see that in the second. So let's run this code now. Ta-da! As you can see, we have amount of records per each year. So those data should come actually per each CSV file. Let's now use Spark to transform some our data from this data frame. So let me create new cell. I will copy paste the code from the lab right now, and I will explain you this line by line. Okay, so what we are doing here, first we are creating new cell which will be year. As you can see, we are using the same function as previously, and we'll create also new column which will be month name, and this time we are using month function based on order date. Yeah, so that would be our transformed df data frame. Now what we will do, we will create a new column which will be called first name, and the value for this column will be split by space, split the column customer name we are splitting, and getting from this split, from this, the result of this split function will be array, and we are getting the first element of this array, which will be everything what is before the space. Yeah, and we are doing similar thing, but with last name this time. So we are getting the second element, so which means it will be after the space. In this way, this is very simplified method of how we can retrieve first name and last name from the one long customer name, let's say. Yeah. Of course, it will not address all the potential options, all alternatives that can be saved in that customer name, but this is just to, you know, demonstrate and simplify this example. Then we are doing filter and reorder columns. So let's see how we can do this. So we are still working on the same variable, which contains the data frame. So what we'll be doing, transform df, we are selecting columns, okay? And this way we will presenting all the columns in the data frame, so very easily. And then we can display this and display only first 5 records from this data frame. So let's run this code and see how it works. So we have all those sales, order number, order line number, and etc. But also we have these new columns that we just calculated, as you can see, based on the order date, based on the customer name. So all those things are similar. So you see that we don't have any longer the customer name, we have first name and last name of the customer. Yeah. Now I would like to, this data frame, I would like to save it to the storage. Yeah, so let me create a new cell, and now we'll this transform df, we are going to write to the storage as a new table. Yeah, write mode. We would like to also use overwrite mode, and we will save this data as a Parquet file. Parquet file is a very popular format, and we'll save it to this location. So it will files, transform data, and orders. As you notice, probably this transform data will be new folder under files, and orders is our name of the subfolder, our name of table. Okay, so let's put the print after that as well, saying transformed data saved. Okay, now what means this overwrite? Overwrite means nothing happened for the first time, yeah, but if we would like to write this again, we are saying, okay, whatever was previously there, please overwrite all those files. Yes, it means we can run this cell multiple times, and it will not fail, because every single time the new data representing this data frame will be saved to this location. Yeah, removing all the previous files, which is great. Below, so something over 1 second, we save this whole data frame to the storage. Now let's check if those files really exist. So let's check here what we have. No files. Let's click this, refresh. Yeah, we should have new transform data subfolder and orders here, and we have our files. Yeah, 3 files, 3 Parquet files has been created, and 1 metadata file. Yeah, which means, okay, the whole operation successfully finished. Now also let's let me show you how to read those data. Yeah, so let me create new cell. So right now we'll read this data to the new data frame using Spark read method. We need to provide the format Parquet. We know that this is the data are present in this folder as a Parquet files, and then we need to provide the location, and a location in our case is this one. So let's use this, copy paste, and then display. So without that, if we run this cell, the data will be load, yeah, to the order df variable. But actually in the same cell, I would like to display this data. So let me rerun this cell. And now we should be able to see all exactly the same data, but just, you know, read from the storage. Great. Let's now save this data in partitioned files. So let me create new, and let me copy that code. So now the same data frame we are writing but partitioned by year and month. Again, mode overwrite, and again I'm providing this parquet location. Parquet is a format and the location is this. Okay, so let me run this cell now. Oh, something is wrong. Order, it should be orders. Okay, so I used order df, so I need to change this here, and then it should be fine. So we have some small troubleshooting process here as well. And now we are writing this data. Okay, so let me now check and refresh these orders we have here. If we refresh this here, we should be able to see some subfolders. Oh, sorry, no, files. We are writing to files partitioned data. Let me refresh this one. And we have partitioned data. And now we see the first partition is by year, the second partition is by month, and under this specific folder we have some data. Yeah, we have one file, one parquet file, and another parquet file here, and etc. etc. There's only subfolders for specific months that appear in this data frame. Yeah, so we see that we don't have data for 2019 for month like 1, 2, 3 and until 6. Yeah, we have data starting since July. And 2020, the same thing, but we have all the months for year 2020. Now, similar to the previous step, let me show you how we can read this data, but this time I will read this data from specific partition, which of course will be more efficient way of reading data, instead of like we would like to read all the data, all the records from one location, from one table. So the approach is the same here. We are reading from parquet format file, and we need to provide the location. So in our case, the location is partition data, and we can provide, because we don't have any kind of like orders here, we can provide year. For example, I would like to read all the data from year 2021. If I don't want to provide any specific months, of course I can. If I don't want to provide any specific month, I can just use wildcard. Yeah, this star character here, which will load all the subfolders in year 2021. Okay, and this is order 2021. So let's rename this variable and run the cell. Control Enter. Now you see that we have data only from 2021. At the beginning we see the November. As you have seen, the native methods of the data frame object enable you to query and analyze data from a file quite effectively. However, many data analysts are more comfortable working with tables that they can query using SQL syntax. Spark provides a metastore in which you can define relational tables. The Spark SQL library that provides the data frame object also supports the use of SQL statements to query tables in the metastore. By using those capabilities of Spark, you can combine the flexibility of a data lake with the structured data schema and SQL-based queries of a relational data warehouse. Hence the term data lakehouse. Now let's create a new markdown cell. We'll say here like, okay, this is create a table, and create another one with the code. What we'll be doing now, we'll be saving the data frame to as a table in the delta format. So let me prepare the code, copy the code. So we are creating new table, writing format this time will be delta, which is delta lake, delta parquet in Microsoft Fabric nomenclature, and we are saving this as a table named sales orders. Okay, and then let's get the table description, because Delta Lake tables can contain some additional metadata about the table. So we are going to execute this describe extended to show the extended set of metadata of this table. So let's run maybe the first both lines, in this case running the whole cell. So let's see what will happen now. Okay, we have data saved as a table, sales orders, and some metadata in a not very consumable way are presented. It's worth noting a couple of things about this example. Firstly, no explicit path is provided, so the files for the table will be managed by the metastore. Secondly, the table is safe in Delta format. You can create tables based on multiple file formats, including CSV, Parquet, Avro, and others. But Delta Lake is a Spark technology that adds relational database capabilities to tables, including support for transactions, row versioning, and other useful features. Creating tables in Delta format is preferred for data lakehouses in Fabric. Now let's see what we can find in the tables here. Let's collapse this part and let's refresh these tables. And you see that we have this table created in our Lakehouse, which is called sales orders. We can click on this, of course, and we should be able to see also the columns for this table. If we take a look on the metadata, we see the same information like column name, data type, and optionally we can see and added some comments. And also we have some additional information about this table, like it's the full name, what is the type, manage, unmanaged, the full location for the files, what is the type of this, what is the file type or provider, in other words, and few others. Yeah. So this is the information that we can get using or executing this describe extended for any particular table available in the Delta format. Now let's read this data directly using these three dots here, and we can load data using Spark. So this will add the new cell in our notebook. So let's execute this cell. Now you see that we are using pure SQL language to read the data, because the table is available as a table in our Lakehouse. So we can use just the SQL, Spark SQL in this case, just selecting and using the language that probably most of you already knows. So select star from lab02.salesorders. Lab02 is my name of my Lakehouse, and the sales orders is name of the table. And also I'm limiting this to top 1000 records and displaying this as a this data frame to the output here below. So let me add new cell now, and this time I would like to write code directly in SQL using just pure SQL here. Yeah, so I need to change the type of this of this cell, saying okay, this time in this cell I will be using SQL. So let's put something like select from sales orders. Okay, I would like to select and use function like year, order date as order year, and another column would be some unit price quantity plus tax. That would be my new column. I will call it gross revenue. From we have already, and then I would like to use group by year, order date. Yeah, because I have this column already here, so I can do this. And order, but the same by the same column. Order. Okay, so yeah, we have our SQL statement, our SQL query ready, so we can run this code. As you can see, I don't use any PySpark code right now because I said, okay, the language in this cell is pure SQL, and this is the result. We have the data calculated, transformed in the fly, and displayed as a result of this execution of this cell. A picture is proverbially worth 1,000 words, and a chart is often better than 1,000 rows of data. While notebooks in Fabric include a built-in chart view for data that is displayed from a data frame or Spark SQL query, it is not designed for comprehensive charting. However, you can use Python graphics libraries like Matplotlib and Seaborn to create charts from data in data frames. So let me add new code and write this code here. Again, I'm using SQL and I'm selecting all the records from sales orders. So let's run this code. But now I would like to change this view, this output, from table to chart. Okay, so let's click on here. As you can see, I need to just format probably or configure this chart a little bit. So let's do this. I can click this customize chart here, and let's add few things here. As a chart type, bar chart. Okay, key would be item. So let's change this. Then values would be quantity. Okay. Series group, I will leave this blank, and aggregation would be sum. And stack would be unselected. Let me apply this now. And now we have our chart reformatted, reconfigured, and the data is much better. Now let me show you something similar, but using matplot library, matplotlib. Let's create new cell. This time I will copy paste this code. I don't want to waste your time me writing this code from scratch. So as you can see, I'm defining SQL query, which would be just select, again, calculating the year, calculating gross revenue from sales order, and yeah, almost the same thing like we done above. And then I'm executing this query using PySpark, and let me show the results. This is how the data looks like. Now to visualize those data, we'll start by using matplotlib Python library. This library is the core plotting library on which many others are based, and providers a great deal of flexibility in creating charts. Let me add new cell here and import library. Import pyplot as plt, and then let me copy that code here. So what we are doing, we are converting this df Spark to pandas. So for the next step, we would be able to draw some chart based on this df sales, which is pandas object. And let's display this plot, this PLT that we prepared using bar method. Yeah, so let's run this cell. And this is our chart. Yeah, it's a plot created dynamically from our code. So again, why we are doing this line? It's because matplotlib library needs or requires pandas data frame. So this what this this function gives us. It converts data frame to pandas data frame. That's why I need to convert this. And then we have this pyplot object that we are defining or configuring based on the data. The default settings results in a usable chart, but there's a considerable scope to customize it. So let's do it in the next cell. So again, what we are doing, we are clearing this plot area here because we already have this object created and we want to reuse this variable. So the same thing, but I've added this color orange here. And then we are customize this chart, adding title, X label, Y label, and some other lines, grid. Yeah. So let's see what will be generated this time. So I can see, as you can see, the data, the chart looks much better right now, and it's again dynamically generated by our code. Now let me modify this code a little bit by adding the creating a figure. So like this, I've added this code here, so I'm configuring the figure, and let's rerun this code again. So the figure can contain multiple subplots, each on its own axis, and the figure determines the shape and size of the plot. So now you can see the chart is much smaller in terms of height. So now let's customize that even more. I will keep this column, this cell, and I will clone that to just not mess this with the same, but also to be able to show you what we are going to change right now. So what I'm going to do now, instead of this, I will create a figure for two subplots. Okay, so this is the way how we can do it. I'm not expert in doing these things, don't get me wrong. I'm just following the instruction here. Yeah, so I never draw these charts dynamically like this, but I see, and I think it's a good way of drawing some charts if you want to have some more flexible and more configurable charts created dynamically by your code. Okay, so this is the one thing. The other thing will be create a bar plot of revenue by year. So we'll change this code and replace it with this one. Okay, so there's axis 0, which is the first one, and we are defining the same thing, setting title revenue by year. And now we do even more, replacing this part with this code. So now we're creating pie chart of yearly order counts on the second axis. Yes, okay. Sales order year value counts, pie, this is the type of the chart as you can see, set title and legend. Okay, now we have this subtitle is sales data. That's it in this cell. Let's run this code. Now you see that we have one big kind of report with two separate charts. Yeah, the previous one that we saw and the our favorite type of charts, which is the pie chart. Fantastic. Now I will quickly show you how useful Markdown cell can be. Yeah, so I copy paste this from the documentation, and I will try to make this with appropriate link. So in this case, the link should be for this Mathlib documentation. So I will use these two words to providing a link. If I go out from this, click somewhere outside, I should be able to see this with appropriate link. If I click this, I will be redirected to the appropriate page in the internet. So if you want to learn more about this, yeah, this is your source. Okay. Now let's use the Seaborn library. So I'm going to create new code. I'm going to import Seaborn and renaming it. And now I'm clearing this PLT variable. And then I'm going to create a chart. Let me copy paste the code. And let's execute this code. Now we have chart generated by the Seaborn library. Yeah, let's modify the code. So let me copy that maybe first and create it as a new cell that I have the whole history of executions. So modify that in the way that before creating a bar chart, I will add this line. And let's see what happened with this set theme. As you can see, the colors changed a little bit. So this is what I mean by using this theme. I will modify the code again. So let me first clone this code to the new cell. And I will modify this, changing this bar plot to a line plot. Okay, everything else remain the same. So let's run this cell now. And now you see I have completely different chart, which is what we expected here. Now again, like previously, I will use this Markdown cell to provide some additional information if you want to learn more. So this will be my cell. This will be my two words that will be connected to this website. Once I click this, I will be redirected to the website. Now, once we finish working with this notebook, we can save this notebook as with appropriate meaningful name. So let's do it. I click this this icon here, and let me rename it. This I would like to start everything with the lab number. So in my case, it's lab 02. And let's name it like explore sales orders. And that's it. Let's close this, and our notebook is safe with the new name. If you want to learn more about Microsoft Fabric, visit communityfabricmicrosoft.com website, which is a fantastic knowledge hub for this product. And in the meantime, thank you very much for watching and see you next video. Bye bye!